Hey guys, we are in our free online coaching classes for the JAM examination video, and this video will be the lecture 12 in this series. And the topic is the chemical weathering, and the book which I referred is The Principles of Geomorphology by William D. Thornbury, Engineering and General Geology by Parbin Singh. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. The chemical weathering or decomposition is a process in which rocks are broken down by chemical decay of minerals. So in our previous class we have discussed about the physical weathering in which the rock has been disintegrated into fine pieces, whereas in this process what happens, the rock has been decomposed and there will be a change in the mineralogy of the rock. And during chemical weathering, a set of chemical reaction act on a rock which changes their mineral to a more stable form. And Goldich in 1938 discussed about this thing, and he had tabulated the mineral stability, in which the topmost mineral will be the least stable one and the bottommost will be the most stable one. And in this we can see the olivine and calcic plagioclase are on the top, which are the least stable according to the chemical weathering, whereas the quartz is the bottommost and which is the most stable which crosses the chemical weathering. And that is why we can see lots of quartz in residual deposits like laterite and other things. And this shows that quartz is resistant to chemical weathering. And you might have seen the same list in a Bowen's reaction, which shows that the order of formation of minerals. In Goldich, this has been explained as the order of destruction of mineral. So one thing is clear, that the order in which the minerals have been formed, the same order the minerals has been destructed. And the water is the main agent of chemical weathering, although water in pure form is inactive to some extent, and it becomes a powerful chemical agent when a small amount of oxygen or carbon dioxide is dissolved in it. Especially in our atmosphere, there is a presence of free oxygen and carbon dioxide, and during rain, this thing will be dissolved in the rainwater. And usually, the rainwater contains these gases, and the main reaction involved in chemical weathering are the oxidation, hydration, carbonation, and solution. So, we will see one after other in a detailed process. The first one we will see is the solution, in which some rocks contain one or more minerals that are soluble in water to some extent. For example, rock salt, gypsum and calcite are few of the minerals which can get dissolved in a water. And there are some other minerals that commonly considered as insoluble may go slowly in colloidal solutions. The next one is the oxidation, in which the oxygen present in the water in a dissolved state oxidizes some minerals. For example, mafic minerals like pyroxene, amphibole and olivine contain iron, get oxidized from this oxygenated water and results in limonite and hamadite. And these are very common products of oxidation, and which shows a red and yellow color in the soil, that results due to the oxidation. So whenever you are seeing a soil or rock which consisting of red color like laterite, it clearly shows there is oxidation taking place in this region. The second one is the hydration, in which the hydration water molecule combine chemically with minerals to produce new compounds. For example, the formation of gypsum from anhydrous is a good example for this hydration. The hydration, what happens, mineral in the rock absorbs water and that actually expands, and during this expansion that creates a stress in the rock and that results in the disintegration of rock. So actually the chemical weathering leads to the physical weathering also during this hydration process. The next one is the carbonation, in which the carbon dioxide dissolves in water to form the carbonic acid, which is H2O3, and which is an effective weathering agent. When mineral containing calcium, magnesium, sodium, potassium react with carbonic acid and produces the carbonates and bicarbonates. And as you know, the carbonates and bicarbonates can be soluble in the groundwater, and that has been removed from that. So the remaining product, especially what we see in the after the chemical weathering, that will combine to form the clay. So as we know, the clay is the ultimate product of chemical weathering, and this is how it is formed. So let us see the results of the chemical weathering. The first one, what happens is the increase in the bulk volume. And as you know, There is addition of oxygen, addition of hydrogen, water molecule, all such a thing is taking place. So there will be a increase in the bulk volume of the rock. The second one is that there will be lowering of density of the mineral due to the solution action and all such a thing, and expansion of minerals as you saw in the hydration, and that results in the lowering of density of the mineral. The third one is the reduction of particle size as you saw in the physical weathering. Due to the disintegration of rock, there will be a reduction of particle size. And the last one is that reduction results in more stable element. As you saw in the series, the more stable element is the quartz. So whatever the initial composition of the rock, that will be converted, and that will be removed due to the chemical weathering, and only the stable elements will stay in as a result in the of chemical weathering in our soil. The zone of weathering, the portion of lithosphere which has undergone exposure to the weather profile, is known as the zone of weathering, and this zone is controlled by the region in which the rock is exposed. Say for example, in tropic and subtropic region, the weathering extends to a greater depth, particularly in the area of granitoid rock. For example, in Hong Kong, the weathering in granitic rock extends up to 200 feet. And there is a term called weathering front, which means the interface between the weathered and unweathered rock has been termed as the weathering front by the Mabut in 1961. So from this class, we come to know that the rock weathering comprises a set of dynamic process moving downwards through a bedrock, but not necessarily everywhere at the same rate. As we can conclude this thing from our class, and I hope this will be sufficient for this heading, that is weathering. And if you still have any doubt, you can just ask me in the comment section. I can explain you with a special video or something. And I group my videos according to the category that you can check in a playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can support us by like, share and subscribe. Thanks for watching. Have a great day.